Hi, my name is Alex Sandoval, and this is my guitar tuner project for electronic instrumentation with Professor O'Foley. So, summary of this project. The purpose of this project is to design a guitar tuner. This is done using LabVIEW code as well as a MyReal attachment and an auxiliary circuit in order to output a signal that the LabVIEW code will be able to read. And then that signal was then translated inside the code, and then it would indicate whether or not the string is in tune or not. The motivation for this project. So, as a beginning guitar player, one does not really know what each of the guitar strings should sound like. They each have their own frequency, and depending on the string, it should sound what frequency it should be at. And as a beginner, you don't really know what each frequency should sound like, and you don't know exactly how to fine tune your guitar properly. More experienced guitar players, they can just not necessarily eyeball it, that that'd be the best term, but they they know more or less what each string should sound like. For example, the E low string has a frequency of 82 hertz. A well-seasoned guitar player, they know what that string should sound like, and they can properly tune it just by simply listening it and fiddling with the knob. And beginning guitar players, they really can't distinguish what the certain frequency should sound like again. And this is where the guitar tuner comes into play. So what the guitar tuner does is it tells the user whether or not the selected string is in tune or not. It'll tell the user whether the string is too high, too low, or perfectly in tune. And so two major questions came up as the project began to advance. The first one was how large of a tolerance the tuner will have for each string. The other major question was how the signal will be input into the code. So to deal with the problem stated above, the tolerance for the tuner will be plus or minus 1% of the string frequency. For example, for the E low string, it has a frequency of 82 hertz. Therefore, the code will have a tolerance of plus or minus 0.82 hertz for that certain string. And it will be different for each of the strings, but it will always be a plus or minus 1% tolerance. An example would be for the A string. So right here you can see that the A string is 110 hertz. So the tolerance for that one will be plus or minus 1.1 hertz, depending on what string it is again. It won't always be plus or minus 1.1 hertz. It'll be different for every string. As for the input signal issue, a frequency to voltage IC was used in order to keep the code simple so you don't have to figure out how to receive the input in frequency in hertz. We just kept it to a simple voltage input. And it helped because it kept the code simple. You didn't have to do a lot of crazy stuff, and you ended up with the same result in the end. So the project description. The project consists of two main components. The first main component is the actual LabVIEW code as seen below right here. I'll get more into depth on that soon. And the other component is the actual voltage or frequency to voltage converter as seen right here. So what the converter does, it receives a frequency signal from an instrument cable that's connected to the guitar. And then that signal is then converted to a voltage, and then the MyRio device picks that up and it sends that into the LabVIEW code, and then the LabVIEW code does its processes and it'll indicate whether or not the string is properly tuned or not. So there were a couple of obstacles that were encountered during the project. In the end, the obstacles were dealt as best as possible in order to achieve the desired results that one wanted. One of the issues was how we were going to receive the input signal and how to manipulate it into what we wanted to. So the materials used were, of course, the LabVIEW software, the MyReal device, and the external circuit that was based around an LM2907 converter, as seen below right here. The circuit with the LM2907 converter outputs an external signal that is about 67 hertz per volt. The signal is then received by the MyReal in order to be input into the LabVIEW code. So right here we have the circuit using the LM2907 frequency to voltage converter. It is powered by 15 volts. And so right here, this was obtained from the data sheet for the converter, and it was for originally for a tachometer, but instead of being used for the tachometer, of course, it was used for a guitar tuner. So right here, the circuit essentially stayed the same. The only thing replaced was this right here. Instead of having the magnetic pickup to pick up the frequency of the gears turning, I replaced it with a instrument cable jack that would receive signal from the guitar and then see what frequency that is at, and then it would output a voltage depending on what frequency the selected string or the string being played is at. And let's see, right here we have the LabVIEW code right here. So right here we have the analog input, the input being the output from the external circuit. And since it's in volts, we multiply that voltage by 67 to give us the frequency that we want. And then after that, we have our frequency. Sorry, my mind went blank. Our frequency indicator showing us what frequency we are currently at, depending on what voltage is being output by the converter. And then up next, we have this right here. This right here is an enum block. So the user will be able to select what guitar string they want to fine tune at the moment. And then that would trigger this case block right here. That would then change depending on the guitar string selected by the enum block. And in here is the actual code that does the comparison for each string. So for each of the strings, the code is basically the same. The only thing changed are the upper and lower limits for the string, depending on the tolerance for that certain string in hertz. So right here we receive the input frequency, and then so this is for the case block for the E low string, which properly tuned should be around 82 hertz. So right here we have the upper limit, which will decide whether if the frequency is below the upper limit. We don't want it above the upper limit. So in this case, the upper limit is 82.82 hertz. So as long as if the guitar string being played, the E low string, if it is above 82.82 hertz, it will trigger this too high LED, indicating that the string is way too high and you should lower the tension on the string. And then below that we have the lower limit. In this case, it is 81.18 hertz. And again, it'll do the same thing. It'll decide if it is less than 81.18 hertz. If it is below that, it will indicate that it's too low and you're gonna have to add more tension onto the string. And the block in the middle right here, it sees the upper limit and the lower limit, and if the input signal is in between those two limits, it will light up the middle LED, indicating that the guitar is properly in tune and it's good to go. And you can go on to the next string, such as the A string, the D string, or whichever string needs to be tuned. So results. So the LabVIEW code successfully converted the input voltage signal into the frequency, and it properly indicated that through the frequency indicator. And it also properly told the user whether or not the string was too high, too low, or just right. Right here we have a table indicating each of the guitar strings, E low being the sixth string, and as well as the thickest string having the lowest frequency. So that's the deepest string in the guitar that has more bass on it. And the E high string obviously being the highest pitched string on the guitar. And yeah. In conclusion, the code was successful as it properly told the user whether or not the string was in tune or not. And if it wasn't in tune, it would tell you if you need to add more tension by saying the string's too low, or adding less or you having less tension on the string by saying that the string is too high and it needs less tension. This project was designed to help beginning guitar players learn how to properly tune their guitar. And later on, as they become more experienced, they might not need a guitar tuner. They'll be able to just play a string and automatically know if the string is in tune or not. But since they're learning how to play, they still don't know how each string should sound like. And the guitar tuner is very helpful in letting the user know whether or not the string is in tune, because you might, in the end, you might have, without the guitar tuner, you might have one string that's just right, the next one might be way too low, the next one's also way too low, and then the one after that might be way too high. And in the end, you're not going to have a very great sounding guitar. Your guitar is going to sound pretty rough, not very good sound in the end. And with the guitar tuner, sound your guitar is going to sound amazing, as long as you know how to play it, of course. But yeah, and below right here we have two video links. Video link right here is for the actual guitar tuner presentation, seeing the LabVIEW code properly work, show how the LEDs work and all of that. And right here we have the poster presentation. So it's not currently updated. It's just a placeholder QR code at the moment. But once this video is uploaded, it will be updated with the proper video that is this video right here. And yeah, that's my guitar tuner project for electronic instrumentation for Dr. O'Foley. And yeah, thank you.